What's up, guys? This is my electric vehicle I built for the Science Olympiad electric vehicle event. Its purpose is to travel a target distance and try to get as close to that target distance as possible. So I built this out of wood and some electrical components, and how it works is that this motor is powered and it spins the back wheels, which causes the front wheels to spin. And as the front wheels spin, this wing nut slides along this and switch this circuit breaker, which cuts power to the motor and stops the vehicle. So how I built this vehicle was I just cut out a little block of wood in wood shop and cut it into 4 different little planks on each side, the front and the sides, and that created a nice frame for the car. And then using like the vertical drill press, I pressed holes for ball bearings to go into, and the inside of the bearings was the size of this threaded axle I bought. So I used, sorry, let me fix this. So after that, the main frame was done, so I hooked on these wheels and the wing nut to the threaded axle. And if you look at the bottom, I also put the connecting gear here. And then you have to make sure the axle rotates with the wheels, because the wheels rotating is what's going to cause the wing nut to move. So you must lock the wheels with many washers and nuts. The washers that I had didn't fit into the bearing because they need to be pressed against the spacer, not the bearing that actually spins. So I found I've had some lock washers were this size that they pressed against the spacing inside the wheel bearing, that they would lock the wheels with axles. So I just jammed a bunch of washers and lock washers and nuts into there, get them locked. I also locked the actual bearings close to the frame, just so that it doesn't wobble around and the actual axles stay in place and only spin. And I also did that for the back. And then as you can see, I inserted this little T section is just another block of wood, and I nailed it in. So that makes sure that as this wheel spin, this hits against this and then skids, and that will allows the little wing nut to skip down this. Otherwise it just not spin, or spin with the axle, sorry. So this allows it to spin the wing nut. And then I also, in the back, cut out this just flat plank with a jigsaw to make a little hole for the motor and the gear. And that just allows me to put all my electronics on top of this. So that is the main build. Okay, for the wiring of this vehicle, it all starts from a battery pack, which supplies the power of the vehicle. And that is, the red wire is the power, so that's connected to the switch, obviously, which turns it on and off. And then that current flows through here to the micro switch circuit breaker. So that is turned on to the power from the switch, and then the wire coming out of it is connected to the normally closed pin. So this circuit is normally closed, so it means it's always powered unless this switch is triggered, and then it will open the circuit and no power will flow. And then that's just connected to the motor, so the motor is always receiving energy unless this is switched. And then the motor is obviously controlled back to the battery pack to complete the circuit. We now know how this is built, but how does it function? How do you get it to go a certain distance? So to calculate that, you want to know the circumference of the wheels, because the amount, the distance that something's going to travel if it has wheels is just the circumference of the wheels times the rotation, because in one rotation the car will go one circumference of the wheel, obviously. So you find your circumference of the wheel, you get like a digital caliper like this, and you measure the diameter of the wheel. So let me do that real quickly. So you see here that it says 3.1156 inches is the diameter. So to find circumference, it's just pi d, pi diameter, 2 pi r. So you do 3.1 times pi, and then you do that by the length you want to travel. So I'm just doing it in inches and here, and I have a ruler of 12 feet, it should say. 144 inches. It got a little messed up. Right here, it was at 12 feet, and then it's just gonna go 12 feet. So 144 inches, and then you just divide that by pi times the diameter to see how many rotations you should twist this wheel back when calibrating the electric vehicle. So in my case, I got that the circumference of the wheel was 9.77 inches, and then I do 144 inches or 12 feet divided by 9.77, and I get 14.73 rotations is how many it's going to take to reach the end of 12 feet in theory. So what I'm going to do is I'm going to try to lift this up with one hand because I'm recording, and twist this to this circuit breaker because that's when the vehicle is going to stop. Very hard with one hand. So twist it to the circuit breaker until it clicks, and then I'm going to see where, so it's around the M in the middle, or just the white. So I'm going to twist it back 15 times to this location because I got 14.73, and in my experience, this vehicle runs a little short. So I'm just going to rotate it back. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Then I'm going to place it at the 12-foot mark. And now I think we're ready to go. Let me make sure the batteries are actually plugged in real fast. And now we're ready to go. So I just press the power button. Let me line it up because sometimes it curves. And then I press the power button and we're off. So I'm going to get a real close-up. Oh, it's going on the ruler, but that's okay. Let's just see if it's accurate. As long as it doesn't touch the grass. That was perfect. It literally cut the circuit breaker right around 12 feet. That's literally the difference of, it's measured from the front, so about like 5 inches. So that's a really good score for this. So I'm really happy and proud with the design I made and its performance. I got 3rd in regionals behind my own teammate on our B team. But it was a really close competition. It was really fun to make, and this is really cool how you can create something so accurate just out of like some wood and some random materials. But there's definitely some big improvements to be made. Like, this is not locked in place, this motor, so literally it like moves, like it's like sideways. So definitely get a motor stand next time if I was redoing this. And in the competition, this needs to be pressed vertically with like a pencil. So I need to like actually cut out a piece of wood and put it in the wood, so I don't have to like chopstick it with 3 pencils just to press it vertically. So that was a big problem during the actual competition, but otherwise it's pretty reliable. And I'd probably just try to do some better woodworking without like splitting the wood, and try to get the thing locked if I was gonna redo this. You were allowed electronics this year, like microcontrollers and the such, but I didn't use it because I just wanted a mechanical design, because that's what I used last year. But this year I built it by myself, and I think mechanical stops are like really cool and more reliable than something electronic. So thank you guys for watching, and I hope you learned a lot and gained some insight into building your own electric vehicle. And thanks for watching. Bye.